So we want to integrate this integral here, x squared plus 15 over x plus 3 squared multiplied by x squared plus 3. And the first thing we need to do is split into partial fractions. Now, if you have x plus 3 or any x plus n in brackets squared, you split it between x plus 3 squared on the bottom and x plus 3 on the bottom. And you have an x squared plus 3, then you make sure to have a numerator of cx plus d. Now to get from there to there, I've got it on the side here. You cross multiply all the terms one by one. So you get this first, you cross multiply that and that, and you get this whole equation. Now, and then you cancel out this x plus 3, which is common within every single ABC term, and then the denominator. Now, if you realize the denominator is now x plus 3 squared, x squared plus 3, which is the same as what we have on the bottom here, which means what's on top can be compared with what's on top here. So we do exactly that. And first we sub in x equals minus 3 to make the b and c term equal to 0, because minus 3 there would make that 0, minus 3 here would make that 0. So then you're left with 12a equals 24, a equals 2. Then you compare the coefficients, the x cubed coefficients, the x squared coefficients, the x coefficients, and the constants. Now, you might find out you might not end up using all of them, but it's good practice, and it's much easier to see and work out what all the A, B, C, and D terms are. So we know what A is. We compare the x cubed coefficients, we find out b plus c equals 0. You compare the x squared coefficients, we find out 3b plus 6c plus d equals minus 1. And then we compare the x coefficients, but we don't end up using them anyway. And we compare the constants, we find out that b plus d equals 1. Now, we know what a is, and we know what d equals 1 minus b. So we sub that into the equation we have here, 3b plus 6c plus d equals minus 1. And from that, we get 2b plus 6c equals minus 2. Then we compare this number 1 equation that we have here and the equation we got before, b plus c equals 0. This implies 2b plus 2c equals 0 as well. You compare it with that, which is similar. So these are simultaneous equations, which should have been covered at GCSE. And then that'll be 1 minus 2. And we work out c equals minus a half. And remember, b plus c equals 0. So b equals a half. And d is 1 minus b. So d equals a half. So now we can just sub in all the numbers. And that's the integral we got here. It's the full integral split into all these partial integrals. Now, we carry on. The integral a, integral of 2 over x plus 3 squared, is that, minus 2 over x plus 3. Now you can just put that to the power of minus 2 and pull out the 2 and integrate as you normally would. B, similar thing, 1 over x plus 3, that would be x plus 3 to the minus 1. And when you're integrating a term to the minus 1, you get ln x plus 3. Now C is probably the hardest. You split this into 2 different integrals again, and you pull out the half at the front, which leaves you with integrating 1 over x squared plus 3 and integrating minus x over x squared plus 3. Now, integrating this, that's a standard integral from the trig identities. If you have a look online or You can even work out this. You can even work it out for yourself. You get 1 over root 3 arctan x over root 3. And then this one's a little bit harder. I've used substitution. So x over x squared plus 3. I set u equals x squared plus 3. Du by dx equals 2x. This means dx equals du over 2x. And this means I can cancel out the x when I sub in du over 2x for dx. And then I'm just integrating 1 over u, which is ln u. And u is x squared plus 3. So I multiply it by the half here. And I get half ln x squared plus 3. So I put that there. Now I just add a, b, and c. And remember to put the plus c at the end. And that's the answer.